Welcome to Math 154 videos. In this video we are going to find the derivative of a function using the definition and then state the domains of f and f prime. So here we have a function f of x equals 1 minus 3x squared, and we're going to use this definition I have on the right here to find its derivative. So we're going to go ahead and plug into that. So we get f prime of x is equal to the limit as h approaches 0. Now f of x plus h, basically what we're going to do is wherever we see an x in our original function, we're going to replace it with an x plus h. So we get a 1 minus a 3 times the quantity x plus h, and that whole thing is squared, so make sure it's x plus h, the whole quantity squared. And then we're going to subtract from that an f of x. So make sure we're subtracting our whole f of x, which is 1 minus 3x squared, right? Because that's got to go in parentheses, otherwise we would come up with an incorrect answer. And that whole thing is divided by h. So then that's going to be equal to the limit as h approaches 0. Now notice this negative in front of our f of x is going to get distributed to that 1 and that 3x squared. So then we have a 1 out front here, minus 1, that's going to cancel, and we're going to be left with a negative 3 times this x plus h squared. We can just expand that, and we're going to get an x squared plus a 2xh plus an h squared, and then that's going to be also added to a 3x squared. And that 3x squared is just coming from this term right here where I'm drawing the arrow. We distribute that negative, that becomes a positive, we get plus a 3x squared. The whole thing is still over h. Now we're going to write equal to the limit as h approaches 0. And this negative 3 is going to distribute to all of these terms. And we're going to notice when we do that, we'll have a negative 3x squared in the front and a 3x squared in the back there, and those are going to cancel out. So then we're left with this negative 3 times a 2xh, which is going to be a negative 6xh. Then we have this negative 3 times an h squared, which is minus a 3h squared. And then that whole thing is all over an h. Alright, so now what we can do is we can factor out an h in the numerator, and then we'll get those h's to cancel with the 1 in the denominator. So we'll rewrite that, the limit as h approaches 0, and we're going to get h times a minus 6x minus a 3h, and all of that over h, those h's cancel, and we're left with the limit as h approaches 0 of minus 6x and then minus a 3h. So as h goes to 0, that cancels out, and we're going to get a negative 6x. So as h approaches 0, we get minus 6x, and that is going to be our f prime of x is equal to negative 6x. Alright, and so for our domain of f, we're going to notice that f is just a polynomial, and so 1 minus 3x squared, we can plug any value of x into there, and that's still going to be okay. So our domain for that is all real numbers. Now we got to look at the derivative, f prime, and that's negative 6x. That's just a polynomial, and so really that also has a domain of all real numbers. So their domains are both the same. So the domain of f is equal to all real numbers, which is equal to the domain of f prime. And that is our derivative using the definition, and we found the domains of f and f prime. So here's our second example. This one's going to be a little bit longer than the first. So we have a function f of t is equal to 4t over t plus 1, and we're going to find the derivative using the definition. And you'll notice in our f prime of t over here, I've put t's there instead of x's just because now our variable is t instead of x. It doesn't really change the formula at all, it just changes a little bit the way it looks. So we're going to go ahead and apply that formula. So our f prime of t is going to be equal to the limit as h approaches 0. And now f of t plus h, we're just going to plug in t plus h wherever we see a t. So we'll get a 4 times a t plus h. Make sure you do the whole quantity in parentheses there so we get the right answer. And then all of that over a t plus h, and then plus the 1. So that's our f of t plus h. Now we're going to subtract f of t, which is just 4t over the t plus 1. And then we divide the entire thing by h, which I am just going to write as multiplication by 1 over h, because it looks a little bit nicer not to have all of those fraction bars in there, but it's the same thing. So now what we're going to do is we're going to find our common denominator here, and so we'll write that out. That's the limit as h approaches 0. Now our common denominator here, we have a t plus h plus 1 and a t plus 1. So we're going to have all of that on the bottom. So t plus h plus 1 multiplied by t plus 1. And then for our numerator, this 4 times t plus h is missing a t plus 1 in the denominator. So we're going to multiply by a t plus 1 over t plus 1. So we'll get a 4 times t plus h times t plus 1. Then we'll subtract from it. This 4t is missing the t plus h plus 1 in its denominator, so we're going to multiply by t plus h plus 1 over t plus h plus 1, and we'll get a 4t times a t plus h plus 1. And that whole thing is multiplied by 1 over h, so really we can just put this h in the bottom here now. So there we are. Now we're going to need to do some clever distribution and canceling to see what we can get. So let's see. We're going to multiply through that 4t plus h times t plus 1. So really we're going to look at this whole thing. We'll take this 4 in. We'll look at this as 4t plus 4h times that t plus 1. So we'll do the 4t first. 4t times t is a 4t squared. 4t times 1, that's plus a 4t, plus a 4ht, now we're doing the 4h, then plus a 4h. Alright, so that's what we end up with there. Alright, and then we'll subtract to it this minus 4t times all three of these terms, so we'll have a 4t squared minus a 4ht minus a 4t, and then that all stays over the denominator we had, which was a t plus h plus 1 times a t plus 1 times an h. Okay, so this 4t squared cancels with that one. We have a 4t here, and a 4t there, and this 4ht and a 4ht. So we'll get this limit as h approaches 0 of this 4h that we have left over our whole denominator, which was t plus h plus 1 times a t plus 1 times an h. And then we can see that these h's will cancel. So we get the limit as h approaches 0 4 over this t plus h plus 1 times a t plus 1. And so as h goes to 0, this h in our denominator is going to 0, so we'll be left with a 4 over this t plus 1 times a t plus 1, because this middle h is going to 0, so that pretty much goes away. So that's going to be a t plus 1 quantity squared. And that is our derivative, which was f prime of t. So we found f prime of t. Now we want to find the domains of f and f prime. So our domain of f is just everything that we can plug into this original function that doesn't give us a 0 in the denominator, because that would be bad. We can't divide by 0. So if we look at this t plus 1 in the denominator, we can't have a negative 1 for t, because that would make a 0 in the denominator. Everything else, however, is okay. So our domain of f is going to be from negative infinity all the way up to negative 1, not including negative 1, and then our union with, again, not including negative 1 to infinity, because we can plug all of those other values in there. Now the domain of f prime, if we look at f prime over here, this 4 over our quantity t plus 1 squared, the same thing happens. If we plug in negative 1 for t, in the denominator we get 0, so that's bad. But all other values for t will work. We can plug them in and we'll get another value out that's not undefined. So actually, the domain of f is equal to the domain of f prime. Now, this is just happening because of the specific functions we're picking. It's not always true that those two are going to be equal, so you need to make sure that if this is what the problem asks of you, you check both cases. You check the domain of f and you check the domain of f prime. Sometimes they're going to be equal, but sometimes they're not, and so we want to just make sure that we double check both of them. And that's it.